So now let's look at some examples involving intervals. So let's start with our first one. For each n in the natural numbers, I'm going to define an to be the interval -1 over n to 1 over n, including those endpoints. So remember, this is this, if you want to think about this in terms of a set, this is the set of all real numbers where they're between -1 over n and 1 over n, including those two values. And so what I want us to do is I want us to find the union or the intersection of these intervals. So we want to find the union from I equals 1 to infinity of AI and the intersection of I equals 1 to infinity of AI. Now these are just different ways of writing our notation. So if you wanted to write these, you could also write them as n is in the natural numbers of AI. So that's another way to write it. But if we're taking the intersection of the natural numbers, we can write it as in these forms right here, where you have 1 to infinity. And so here I have an infinite number of intervals that I want to take the union and the intersection of. So when you're doing intervals, it's kind of nice to be able to visualize these intervals. So let's visualize some of these. Let's start with our first interval, A1. So if you go back up to our formula here for AN, plug in n equals 1, and what interval do I get? I get the closed interval, -1 to 1. And let's draw that on a number line. So here's 0 in the middle, here's -1 and 1, and I'm going to fill in everything in the middle. And because this is a closed interval, I'm going to include my two endpoints as well. So I'm going to use filled in circles here. Now let's look at A2. A2 would be -1/2 to 1/2. So make sure that when you're doing this, you line up your number lines so that all the numbers are located in the same spot. So here I'm going from -1/2 to +1/2, including my endpoints. Okay, and let's do one more. Let's do A3. A3 corresponds to the interval -1/3 to 1/3. So again, draw your number line and make sure you're lining up all your numbers with your previous diagrams. So here, maybe -1/3 would be there to there. That's a little there to there. So there's my number line. And so now let's say I want to take the union of these pictures together. Let's start with our union. The union. Well, what's happening? So if you look, you have A1, and then what happens in A2, if I look at A2, the part that I shaded in is contained in A1, right? So A2 is a subset of A1. And then if you look at A3, A3, the part I shaded in an A3, is also contained in the picture for A1. So A3 is also contained in A1. So basically, as I keep going down, my intervals are getting smaller, and they're all going to be contained in that first interval there. So this union, it's going to correspond to that first interval, -1 to 1. That would be my union. Now let's look at the intersection. So with intersection, I want to see what do they have in common? Where do they overlap? And so if I look back at my pictures, well, these three intervals all contain the number 0. So if I look here, let me erase some of this. If I look here, all three of my intervals contain 0. These intervals are all centered around 0, and what's happening is my intervals are pushing in towards 0. So they're all going to contain 0, and remember the sides keep pushing in and pushing in. And so in the end, I know that 0 is in the intersection, and it turns out to be the only thing in the intersection. The intersection would be only 0. Because remember, sorry, not n, these should be infinity here. Because remember, you're taking an infinite number of these intervals. I've only sketched out 3 of them, but the intervals are going to keep getting smaller and smaller towards 0. So in the end, when I take this intersection, I'm only going to be left with the element 0, and that's it. So it's just a single number. It's no longer an interval.